Hello guys, my name is Dipti Ranjan and welcome to Intel Indexer. First of all, I would like to congratulate you and also Happy New Year. Uh, Let me just tell you what this session is going to be about. This session is going to be about the RNN and LSTM model building technique using Quandl dataset. Uh, so uh, the whole model that I'm going to build and show right now to you is going to be a very basic one, and we have been working on some complex ones. After having knowledge of this basic one, you can just dive in directly to the complex ones and tinker around to create your own new models and also do some modifications in the present one. So I hope that all of you are familiar with neural networks, and right now I will just guide you through the whole process. So first of all, whatever we have been doing over here is all in Jupyter Notebook. Initially, you have to do it in Jupyter Notebook, and later you can just make a Python file and you can use it. And the whole process is to be automated later on, so it's better to make a Python script after you use Jupyter Notebook. As of Jupyter Notebook, most of you must be knowing that it's browser based, and all you have to do is like type. Let me just show you what how can you get started with it. So okay, so you can just write Jupyter Notebook to start it, and whatever your default browser is, it will it will run on that. Like here, this page will be shown to you, and whichever terminal you wherever from which place you are using the terminal, it will show all the files. And later on you can go here and you can just make a new Python script which will basically make this blank one, and or you can just if means since sometimes it opens in Google Chrome, so I would rather use Jupyter Notebook minus browser and Mozilla. So after doing that, what happens is that you will be one second, yeah, you will be given a link here. Jupyter Notebook is running, and this is the link you will get, and you have to just copy and paste it. So you will get again this page if you have a preference in like browser, like I have Mozilla over here. So yeah, first of all, let me tell you what kind of data we are dealing here. It's financial economical data, and some of you might be working on stock data, or some of you might be working on any other data like GDP or events. So to start off, we are going to use Quandl. Whatever testing you are going to do, you do it using Quandl, because later on we will be having a database built itself, so you don't have to do API calls and get the data. So yeah, first of all is you have to sign in, make an account. It's completely free, and Quandl has this vast amount of data ranging from as you can see, FX rates or stocks, microeconomics, and also alternative data, but which are basically for premium users. Premium are the ones who basically pay for the data, and since you guys are testing, so it's better if you use the free one. So like here I have used the free one, and let's say I want to use the data, like I want to know the stock price of Goldman Sachs. So here I do Goldman Sachs. Okay, so as you can see, wiki Goldman Sachs group, and this data is free. So like that, there are many other exchanges also you can get. So usually this is the exchange. Here we are getting the wiki, but the whole provider of data, and here we have the symbol or the company you want to get the data of. Instead of this, you can put in some other like symbol such as USD or Euro. You can get values for that also as well. So okay, I think the server is down for some reason apparently. So yeah, what exactly these data contain is uh, just the simple. Let me just go to wiki uh, GS. Okay, just for one, this is not Goldman Sachs. Uh, okay, so they're having some trouble right now. So let's say for stock like normal uh, Goldman Sachs. So what kind of data you have for them? So you have like open, which is basically the like the price at the open of that day, like or the price which it started on the trading day, and then we have close, in which it basically closes like if a day is profitable, then the open will start at let's say $23, and then if it's profitable, then it should end at a good amount, right? Let's say 25 USD. It ends at the same day it ends at that. Then we have high, which is basically the highest that it achieved in that, because like there might be many fluctuations, so it might be possible that the highest that the stock achieved at that day might be 29 USD, let's say, at some time during the afternoon. Then we have low, which is the lowest it can go. Let's say it went to 22 USD that day, right? So then there's volume, which is basically the volume traded, and then we have other data. These are the basic ones, and these are usually free on Condel or any other place you can get this data for any company. So for Goldman Sachs, we are using SP. We are using, since Goldman Sachs is in SP 500. So these data are from there. So you can use data from BSC as well, or you can use from Hong Kong Exchange, or you can use from London Stock Exchange. There are pretty much a lot of exchanges, Tokyo also. So all these data are available. At this moment we are facing some issue in Condel itself, but this is what you are going to get. And as you guys saw, let me show you once more. Okay, so this is the way you have to access it, which I will explain it to you right now. So first of all, what you guys have to do is, yeah, apart from these data, we have adjusted close, adjusted open, and all. So these are pretty much same, but adjusted close is after giving out dividends or other things, whatever the value is left at that day. And of course we have the date also. It's in some format like 22 12 17, like 2017 or 2017. You have to just check that out. Okay, so date is like date time format. So the major libraries that we are going to use here are pandas and numpy, because it's pretty much required for visualization. We need this, and okay, we don't need k-means here. We have to normalize data, and normalize is because whatever data we have right now, we have open, high, low, close for a company. Let's say it's overall like it from 10 to $50 in a year. It has basically changed, but the volumes are in like more than million, like let's say 10,000 or some like million or more than this might be the amount of volume that's been sold. So these values are pretty much different, so we have to normalize each and every data. We have to bring it into a range. Each and every one should be in a similar range, like 0 to 1, or any other range, because if a data is very large and we do not standardize any of those data, then what happens is the model gets tuned to the data which are having a much more difference, like the volume, as I said. So a smaller change in volume can also change prediction in the model by a large amount. So you don't want that kind of bias to be created for any kind of feature. So here okay, so yeah, moving forward, we have date time. This is for the date. So here we have Quandl, import Quandl. So this package, Quandl, they have, you have to go to the, after you open this, or you can go to your profile, and you after signing in, you can go into their APIs and check that. Basically they have made a interface for API for any users in R or Python. So you can, what you can do is, rather than just going out, clicking on the company and downloading the CSV file and then using it, you can just make an API call that, okay, I need Goldman Sachs price. So Goldman Sachs price will be provided to you. Okay, you just have to give your key, like after signing in, after making a profile, you are given an API key. I will show you my key, but don't use it because I don't change it that often. So it's free, like you have to make a API key. So after that, you can access any kind of free data that is available. If you are a premium user, you can also access premium data. So yeah, then this we have train test split, which we won't be using here, but you can use it later on. Mean squared error, we have a lot of matrices to, basically matrices to compare different models. So mean squared error, we can use as anything we can use, right? Root mean square and all. Yeah, plot is basically when we want to plot a graph or any kind of visualization, histogram or frequency. So we need it. In this video, I will just show you how to plot a graph just on the test data set, and others are pretty much sure. Yeah, so here we have the important ones. So since we are using Keras, so what Keras is exactly, it's a wrapper around TensorFlow or Theano. Okay, so you might be knowing Google's TensorFlow and Theano. These are very much low level, right? These are much like C++ in their approach, and it's very tiresome and very much, you know, difficult to write a script on a TensorFlow. Like for the same LSTM model that you are going to do over here, or GRU or normal neural network, you have to write like around hundreds of lines in TensorFlow, but here you can do that in couple of lines, 3 to 4 lines. So it's good for making prototypes, but later on, if you want to make a modification which is very much subtle in nature, like you want to branch out your prediction, you want to branch in different inputs, these are some which are like fundamental level of changing. So there are many, like for now Keras is pretty popular library, so there are pretty much a lot of modifications that can be done. But at this point, yeah, so we have dense, we have sequential, because we are going to use sequential model, and then we have dropout. I will explain each and every one as we reach the training part. Then we have activation, and so here what I have done is I have imported all three of the RNN type of data. So we have normal simple RNN that we know, like majority of us know. Then we have LSTM, which has basically 3 gates, and it's much more efficient when it comes to long-term memory, and it's better, but it takes a lot of time. GRU is similar to LSTM, but it has only 2 logical gates, and I hope you might have gone through any like some blogs, like pretty much simple blogs. I will be providing you the links if you want, but yeah. So yeah, over here we are not going to use conv and other things. Yeah, Python image is just to display the image. So here you have to, as I said, like we have Quandl, and so for accessing the API, you have to put in your key. You as you make your account, you will get a unique API key. So here this is my key, and I have put this in API config.api key. Okay, so let me run this. Okay, now let's see what exactly we were searching for was Goldman Sachs, right? So you can see we have wiki / Goldman Sachs. We have also wiki / Apple if you want, AAPL for Apple, for NVIDIA, NVDA. So these are the tickers, the symbols of the stocks, and this is the database from where you are getting it. or you can also refer to exchanges. So what I have done is, like, I have made a normal string for wiki, and here you can just put in any of your company's data you want to uh, extract or train or your model on. So after that we basically combine it. So what exactly the search column is, it's nothing else, it's just the same. uh, Let me just show it to you. It's going to be wiki slash gs. Okay, so this is what it is, and we are going to put this value in here, quandl.get. So what this will do is it will send a request to get all the data set, or the whole data set of Goldman Sachs. If you want, you can put in put a comma, and you can put the start date, end date. So all those instructions are given in this. When you click it, it will be shown. So yeah, let me comment this thing out. Just delete it. So what does this return exactly? Is a data frame, right? A pandas data frame. So okay, so it might take a few. Okay, it's completed. So let's see what's in df.temp.head. Only the first 5 rows. Okay, so we have date over here, 1995. This is the 5th month of the year, and this is the day. Uh, so it has basically returned the whole time that Goldman Sachs has been on the records from 1999 to present date. As you can see, for present date, if you want, just tail it. Okay, so we have 2017. Okay, so the latest data which we have is 29th of December, right? So what exactly this data contains: open price, high, low, close, volume, ex-dividend, split ratio, adjacent close, adjacent high, low, close, and volume adjusted, sorry. And for this particular video, we should just to make it more simple, I'm just going to concentrate on this 4. Okay, and out of this 4, I'm going to just predict the closing price of the next day. That is basically with all the data of 2017, 12, 22, and any data from before. We'll be predicting this value. Okay, so you can edit the network in such a manner, like it can give more than that, like it can give this day and this day and this day with that prediction, this much of data. You can just do this day on that particular day, what's the closing price going to be. So it's up to you. So yeah, so what I'm going to do is I'm going to save this file in like this data frame in another one, df, but we are going to just save open, low, high, and close. Okay, so for that we use the dot loci location. So this dot, we have different uh, like ways to assign to access the data in the panda frame. We have a dot ix, we have dot iloc, we have dot loc, but location is used for when you are giving the data's, sorry, the columns names. Like here I have given open, low, high, close. If you are giving just the indices, right, you can use I. So you have to put in like 0 for open, 1 because this is the 0th column, this is the 0th column, this is the first column, first, this is the second, and this is the third. So 0, 1, 2, 3, and this this is comma separated because whatever is on the right side is basically the columns, and these are the rows. Okay, so if you are just putting a column, it means that you are basically accessing all the data, like every data, but we are going to just get only these 4 as output. Okay, and if you want, you can just put in like I want from the 5th day, sorry, because we are going to use this 6th, it's going to be I minus 1. It starts with 0 to the 11th, right? So it's like that, but we are going to use the whole, sorry, what kind of flexible type. Okay, so yeah, as I said, since we are using the columns, we have to refer it as log. Okay, so let's check what the data we have. So you can see we have trimmed the data down to only 4 columns, and all the means whatever we have, the total data frame of that from starting. So if you want to know what's the dimension of it, so as you can see we have we have 4 columns, and we want to know how many rows are there. So yeah, shape. So here you can see we have 4696 rows, and we have 4 columns. So I think you all are clear with that. Okay, so now we will go to the data conversion part. So why exactly we have to convert the data? Now with a normal neural networks, and like normal any of the mechanism, let's say we have feature x1, x2 and x3, and we have to predict y, right? So what exactly we have, like we have 1 1 sorry 2 0, and y is 1. Similarly we have something like this, but y is 0, right? So like that, these all are columns, and we have the rows. These are each feature x1, feature x2, feature x3, and this is the output y. So what happens is we are using a time series data, and time series data are dependent on the value that was before them, right? Because here we have another thing, that's basically the time, right? So at t1, the day 1, let's say t1 is day 1, t2 is day 2. So at t1 the values of the features was this, the output was this, right? This is the, let's say, closing price. Okay, and on the second day we had this values, and similarly for the third day we will be having some other thing, right? Let's say for the third day we have this. So what exactly happens is, like when you're talking about stock market or any kind of time series data like word prediction, these data, like whatever the values of the data were before it, will eventually affect this. It really matters what your stock value is today, based on what the values were yesterday or day before that, or 20 days or 100 days before that. So for this only we use RNNs, LSTMs and GRU. So all these 3 models are used for the specific reason of using it. So yeah, if you want to just run it, like one thing I would like to say, like you can click this, or you can just press shift enter to run each module. And this is the best part of Jupyter Notebook, you can modularize your code into different parts. So whichever part you want to rerun again or do some changes and just run that particular part, you don't have to run the whole code again, right? You have to just make some changes. Okay, so in RNN, I think most of you have the basic knowledge that the output of the hidden is basically fed into the another hidden layer as an input. So what exactly it is as I said, let's say this is the like we don't have x2 and x3 over here, we have just x1 and h0, let's say. Okay, h and x. So what is happening is, this is on the 0th day the value, the first day, the second day, and this, let's say, some other day. Okay, so the output of the hidden is going to be the input of this, as well as we are going to get the input of that same day. So then we are going to give the output of this day as input to the next days, and this is the next day, like the third day. x2 is the third day, this is first day, this second day, this is the third day. So let's say we are not going till this much, we are just going to use these 3 days. We are going to take input of each day, t0, t1, t2, and we are going to predict the output of t2. That is what we need, the closing price of t2 or t3, let's say that. Okay, yeah, So this is the data conversion that we are going to do. Okay, let me explain it to you in detail. So I have made two functions, that's very simple ones. So okay, we have the data. So what this is the input that is coming in, like the parameters, the sequence length, the number of days. As I said, we had 3 days over here. You can take 25 days, 20 days. Here we are going to take 25 days. So here, and this is the input features. What we had was open, low, high, right? And the output is close, right? So these are going to be our input features. This is going to be the output feature. So the target over here is going to be close and of t plus 1 day. Okay, so you have to do some adjusting in the data part. T plus 1 day, and these are on t. Okay, all the others are same. Here, okay, so what we are going to do is first of all we are going to sort it by index, which is already sorted, pre-sorted, because we have date in the index, and then we are going to separate the input features and the target features. So what exactly we are going to give as output is, here what I have done is, like, we are getting 3 outputs, right? The input as an output, like whatever we will be getting open, low, high, open, low, high in data dot input. These are the inputs that we are going to give to the model, and then we have data dot output, that's going to be the close, and for later on to match using the dates, because dates we cannot use as an input feature, and whatever conversion we are doing over here in pandas and all, these are basically converted into numpy, and saving data any value in numpy is not going to be very effective, because whatever model you are going to use in Keras, it's going to take numpy as an input. Okay, it does not take pandas data frame. So we will keep a separate file for, like, data dot dates, data underscore dates. These can be accessed later on to realign all the data in according to the time frame. What exactly we are doing is, we are converting the data into a time series over here, which is in format, as we saw previously, the shape of one second, yeah, shape of the data frame. So what we have over here is like 4694 4 as the number of parameters, right? So what exactly we are going to do, the type of format that Keras uses or takes as input is going to be 3-dimensional. So what exactly is happening? It's not exactly a pure 3-dimensional, but let's say 25 over here, and this is 3. Okay, so this is open and low and high. This is the input that it's going to take. These are the numbers of means whatever the values are of open, low, high. These are the number of days. As I said, we have 0th, 1st, and 2nd day, for 0, 1st and 2nd day. So this is going to be used for this. Instead of, like, we could have like only 3 days, 4 days, here we are using 25 days. So what does that mean? It's going to use, it's going to use 25 days data before today to predict today or tomorrow, whatever you want, like any days of number, but you have to change the data. Means if you want to predict the value of today, then the output that we will have, for, as you know, like, we have something to compare, like while training a y parameter, so it should be of today's. If you want it for tomorrow's, then t plus 1, day after that t plus 2. Okay, so these are these are the number of days, let's say, rather than using because this is a whole lot of data, and I would prefer using only 1000 day, let's say 1000 days. So it's a thousand. Imagine this as 1000 rows, but each rows contain 25 rows of data, of 25 rows of data before it. Like let's say this starts not from 0th day, this starts from the 100th day. Okay, 1000, 100 to 1000 and 100. So what does 25 mean? It means it has the low, the as you can see, the 3 is the number of this parameters. So 25 is basically 25 days of data of low, open and high before the 1000. Like it's from 975 to 1000. Okay, so these 25 days of data in between this time frame is contained in one of this, in one particular row of this. Okay, so I think you guys have a pretty clear idea about what this thing is. Don't worry, I will share the code, so later on you can check this. These are pretty basic parts, and these codes will be used on the complex ones. So right, you don't have to write all these codes again, but yeah, if you want to do some checking or if you want to do some modifications, then you are most welcome, because yeah, there is always scope for modification. And these are basically wrapped into particular packages, so that rather than just doing all of this, you give a call to this function and you pass in the parameters and you will get the output. So you don't have to worry about any of this. Whichever function you are seeing here is most probably converted into a package. So okay, so next we have get, train, test, validation. So what we are doing over here is basically this function, this whole function is going to call this function, and it's going to get the data, and eventually it's going to give you out y train, x train, y train, x test, y test, and date of train, date of test. Okay, so this let's say what happens over here. Okay, so after calling this function, since I have already run this function once, so I don't think we need to do that again, but just in case. Okay, so what happens is we are going to send in the data frame, then the sequence, the number of days, the target, which is going to be our close, and then we have the starting date of train, the ending date of train, the starting date of test, and the ending day of test. So we had all the sequence. Like we usually you might be knowing that we divide data into 70s to 30 or something like that, to divide it into train and test, and then what we do is basically send this data. We use 70% of the data to train, and the remaining we use, the 30% we use to test. So we get some kind of score matrices from there. But right now we are using a time series data, and to give it a more flexibility in its approach, what we are going to do is, rather than 70 and all, you can just as you can see over here, you can just mention the dates, the starting date of the training data set. So it's going to start from 2011 January 3rd to 2006 6 and 13. It whatever data is in this time period, it will be used for training, and this will be used for testing. These are the number of days, the sequence, the target, which is basically close. Okay, so here I have made the call to this function, and this function in place will call this function, which will give it data. So what we are going to get over here, let's see, let me just bring this down a bit. Yeah, so I have run this code already, so we don't have to run this, but yeah, it won't take much time. This was fast. So you can ignore this messages, because all that basically update and all. So yeah, so we have the X train. So these X train is basically your input parameters for training the model. Okay, what's Y train? It's the corresponding output whatever we have for training dataset, same training dataset set for the model. So yeah, sorry, Y train. Similarly for X test, this is something we are going to use for test. This is something Y test is we are going to use for testing. Like this is the output. These are the input. Like these are the input parameters. This is the output, and then we have date train, date test to just get the date values. Okay, so what exactly a X train looks like after conversion into NumPy? This is what you get. This is open. This is low according to whatever we had done over here. Open, low, high. So it's basically arranged also, you don't have to worry about that. And this is the high. So this is of the 0th day, this is first, second, this will go on till the 25th day, and this is one value used for training, and its corresponding output for the first one is going to be 168. Okay, so yeah, so you can just check it like dot shape, sorry, yeah. We have trainings shape. This is the output that you got. As I said, we have 1345 days, 25 sequence, window sequence, you can say, open, low, high, close, so 3. So we have only train 1, 3, 4, 5. This means you have only one data, and like it's one-dimensional array. Okay. So yeah, so I think you got an idea about all this. Next, let's move to training part. I will explain what this is. So for training a model, we can use a lot of models. Here I have used let's start. Basically in this function what we'll do is make a sequential model here, and we in Keras we keep adding sequences, we keep adding the layers to the model, so it basically gets a lot of burden from your head, and you don't have to worry about all the things you have to do in TensorFlow. So here we have simple RNN, number of hidden layers, number of hidden nodes over here. I have kept this to 256 by default. If you want, you can change it. You can give a input that okay 100 and something. Return sequence true. Activation function, that's ReLU, and you can use different also like sigmoid. We have tanh, but ReLU is the best you can get, best output that you can get from there. Then we have input shape, which is basically the sequence length and the number of attributes. So it will take this too, and it will basically loop through these data to train. You don't have to worry much about that. Okay. And then we have dropout, which is basically while training a neural network, let's say we are using all the nodes, but with dropout 0.2, it means like 20% of the nodes will be disabled while training at some point of time in a random sequence. It's not like only particular nodes will be blocked. Couple of blocks, it will be blocked in a all those will be disabled in a sequence. And what does this do is basically it avoids overfitting the model, because if you are using all the nodes, then there's chances are that all of them are fine-tuned for it, and with introduction of a very new kind of data set, it might not be able to perform well. So yeah, so this is the second layer, and this is also having activation function. We have return sequence as false. So now I will tell you what exactly return sequence is. As we had seen earlier, we'll take 3 inputs, we'll get 1 output. So we have many to 1 output, like that's the whole point of it. So the first layer itself is showing it's true. So that means that the number of sequence that we get in input, that will be also the number of output. So whatever we are going to put in here, like we have 256 days as input, so the output will also be 256, no like outputs. So whatever we are going to get, whatever layer we have next to it, it should have 256 input as well. And this exactly means, like, if we have 256, then we can just make it 1, and it doesn't have to, like, it can be just put in the output part where we need only just one value. So yeah, since we are return sequence is true, which means 256 output, we have 256 input over here. We have put a return sequence as false. We are using activation function relu, a dropout of 0.2 and then 1 input, and we are going to apply linear activation function over here. So this is same to many to 1 in this case, sorry, only this case, and it's many to many in this case. Okay, so the loss we are going to use is MSE, basically mean square error. Optimizer that we are going to use is Adam. We can use different, you can use stochastic gradient or any other. We have a lot of optimizers, but Adam is the most, by far, best optimizer available right now in Keras. It might not be true for all cases, but yeah, majority of the cases it's true. We can use RMS prob also, but yeah, it's up to you. Then we have history, which so here we fit the model using the training data set input and output of the training data set. This is x1, x2, x3, whatever it is, open, low, high. This is only the closing prices. The batch size, it's up to you how much you want. The number of epochs, it's basically the number of iterations you want. Validation split is like out of all the, like, if you are using 100 data sets to train the model, then 0.05, like 5% of it will be used as testing, like just like testing, but it's done while doing our training part. So it will be used for this, and the history is basically for recording all this value. Means with each iteration we will be getting a low error, and the error will be reducing after each iteration. So it will be stored in the history, and eventually we will return the model which we have trained, and we will be returning the history or whatever history it is. Verbose is basically 0. It's a boolean value. You have to put as 0 or 1. 1 basically will, it will just give you, while training, it will just show you an output, like what's the error and other things and how exactly it is going. But I would recommend using 0, just in case you are curious like what's going on. You can just change it to 1. But if you are having a very long number, like a very high number of epoch, then I would recommend 0 is better. So we have a basically a function defined predict. What we are going to do is, whatever model we got over here, we will use its predict function to basically get the output predictions after we train it. So yeah, after basically running this, so here we are running the model. We are going to call the model and pass in the training x input parameters, output parameters of the training data set, the sequence length, which is 25. We have mentioned here 25 sequence length, and then I have commented this out, but you can uncomment it. This is the RMSE of the whole value correlation, and you can get all other values also as well. Yeah, so we have the model. We'll get the model, then we'll make a call to model the prediction, basically the prediction, and we'll just check what's the output going to be. Then we are going to calculate the RMSE and RNN value. So for this, what I have done over here is I have disabled the normalization over here. So what exactly does that mean? Like, whatever value we had, we have like 256 USD or something, and it fluctuates in a year, or in 5 years it fluctuates between 100 to 300. We have scale this down to 1 0 comma 1. So your 256 will be something like 0.55 or something like that. Okay, so it's basically normalized. Every value is scaled down to this range. So as I said, it's very important to normalize your data, but for here I haven't basically done it. Since whenever you normalize a data, it's you should also denormalize it. You should also add a function to denormalize it. We have done that also, like whatever code you are going to get after that, the complex model, but I would suggest you guys to give it a try on your own to see what happens. So yeah, after training, what we do exactly is we get the predicted output from for the all the parameters of test data set, and then we use date that we had extracted earlier to make a data frame where we'll just put the predicted test, the real test value, like these are the predicted ones, these are the real ones, and arrange it by date as index. So this is what we are going to get as an output. So let's say this model wasn't trained good enough, like we were using simple RNN and we are not using LSTMs or like that. So there might be a lag or offset. To clear that, you can just realign the graphs on top of each other. So yeah, so we'll get, this is the date, this is the output, and the shape. This is the shape of the testing data set. We have 362 days for testing over here. Okay, let's plot. So we are using matplot over here, and we have basic things over here, so let's do it. Okay, so since it wasn't trained that well, you can see that all the orange one are the predictions, and the blue ones are the real values. So you can see the model has been able to replicate the whole fluctuations and everything that are in itself, but yeah, you have to make up for the basically the offset. You can do it by basically measuring the distance and subtracting it from, sorry, adding that value to the prediction. It will just move up in the graph. So yeah, so guys, this is all we have right now. You can see as the value over here, we have from 140 USD to 260 USD, and the prices are fluctuating, and these data are for year 2016, month of 7 to 2018. That is today, right? Okay, so yeah, so what I would like you guys to do is after like getting this, try to do a few things. Like first, I had used Wiki.js. I would like you to use since you are like 3 guys, one of you will use Hong Kong Exchange, and another one will be using London Stock Exchange, and just get any country any company you want. Someone with let's say BSE, Bombay Stock Exchange. Okay, so do the predictions, get the output value as soon as possible, because this is the simple part, right? If you catch up with this as soon as possible, we can move ahead, we can do some other things also. So yeah, and also if possible, you have to, like right now I've just put an option over here, you have to add some feature, like let's get the user's input, what exactly it's going to be. And there's one thing, as you saw over here, we have a gap, like the trading was closed between 22nd and 26th. 23rd, 24th, 25th were holidays. So while using these data set, start date, end date, train, if this value is not found here in this data frame, it will give you an error. So yeah, make a basically a system or something like a exception handler to basically check that. Or like if there is an exception and you find out, okay, this data is not there, then make it jump a day ahead or a day back, let's say a day back, a 1 day or two, means how many days back it's required to get the data. Okay, like the exception shouldn't be shown to the user, right? It should be done completely inside. So this was the second thing, like for date exception, sorry, handling, like, okay, you have to automate that whole part. So this is the basic thing that we are going to do, and after that, basically, if you if you have this knowledge, we can divide the work between you guys. Like, we have some of them will be the use will be handling the complex model. You have this is the simpler one. So one of you guys will be handling the complex one, like making more layers or something, using different algorithms that are available, or then we have yes, more layers or something like that. And what we have, sorry, some of you will be working on the automated, oh, I'm doing really bad in this trading part, which is basically small, but what we have done in the complex one is we have made a backtesting mechanism. Like, rather than just showing the test here, what we are doing is we have made a back test, right? Let's say we have $100,000 and you invest, and you say that, okay, I will invest in Goldman Sachs. So after 100 days or a year or something like that, what's the return you are going to get? So we have the back testing mechanism that is also made up. So we have to do some editing in there, or we are basically looking forward to add machine learning over here itself, which will be similar to this, or as well, but you guys need to have the basic knowledge of this. And other part is basically visualization. So visualization is like, we need graphs, or we need histograms for returns. By the way, all of these are done, so you don't have to write don't have to write from scratch any of this that is available here. But we need you guys to means whatever you are going to do over here is also made, but we need you guys to get the hang of what we are going to get doing here, so that it's much easier for you to transit into the complex stuff, which is not that complex, but yeah, this is the most you are going to. So think, and if you can come up with ways to, like, modify it or make it more more of a system that requires less of human interference. That most human interference is basically the input, let's say input of dates, or and date and the stock, or whatever it is. You can come up with any idea, that's going to be really great, right? And then yeah, for now, yeah, you guys try to do this simple stuff, and all the best. Please get in touch with me if you have some doubt or anything you can't understand, and yeah, all the best. Thanks.